So this is my first Quideo, and we are going to start off with the basic question. The basic question has to do with the metabolic rate and the lean body mass of 12 women who were subjects in a study of dieting. The researchers wanted to see if lean body mass has an important influence on metabolic rate because they believe that to be true. And metabolic rate is the amount of calories burned per 24 hours. Part A asks to make a scatter plot of the data that they give you, and they gave 12 lean body masses and 12 metabolic rates of the women that were interviewed during this dieting research. The lean body mass goes on the x-axis and the metabolic rate goes on the y-axis because the researchers believe that the lean body mass would be the explanatory variable because it would explain the metabolic rate that these women have. Part B of the basic question asks about the direction, form, and strength of the relationship on this scatter plot. And I said the strength was very strong because as I've drawn out, most of the data stays within the same general area as it increases. If there were more points outside of the lines that I've drawn, then it would have made the graph weaker, but there was only that one point right above 1400 and at 42 that made it maybe a little less strong, but since 11 out of 12 points are found within that area, I would say it to be a pretty strong graph. I would also say that it is positive because it goes from having lower points to having generally higher points, as opposed to a negative scatter plot, which would have higher points first and then it would gradually get lower. So it's definitely positive. And it is also linear because just like the lines I've drawn, they form a line, making a pretty strong linear graph, as opposed to nonlinear, which again would have more points outside of those lines. The advanced question asks about boys who have completed this test that measures how long they can walk on a flat, hard surface for 6 minutes. They asked age groups to do this test, ranging from 3 years old to 18 years old. And out of those age groups, they had representatives that represented the age groups. So from 3 to 5, there was a 4-year-old. From 6 to 8, there was a 7-year-old. From 9 to 11, there was a 10-year-old. From 12 to 15, there was a 13-and-a-half-year-old. And from 16 to 18, there was a 17-year-old. And they gave us their 6-minute walk distances in meters. Part A asks to find the least squares regression line of this data, and a least squares regression line follows the formula of y equals a plus bx, with b being the slope. And for this particular equation, it would be y equals 492.7977 plus 14.7633x. And the slope in this problem represents the regular increase of about 15 meters when the age increases. Meaning that, in general, when a boy's age goes up, the walk distance also goes up by about 15 meters. To find this formula on your calculator, you need to put the representative age into the x-axis, which would be L1, and then you need to put the walk distances into y, or L2, and then go to stat, and then calc, and then press 8, and that will give you this formula. For part B, it asks you to compute the residuals, and since you already found the least squares regression line, all you have to do from there is go into L3, which is stat, and then edit, and then arrow over to L3 and go up. And then you put resid into that. And then it gives you these numbers, which would be negative 7.551, negative 12.14, 26.869, 8.9974, and negative 16.17, which gives you this graph right here. It asks if there are any unusual features on this graph, and the only thing that I would say is an unusual feature is that 4 out of 5 of these residuals are within 17 of the regression line, which is 0. But that 1 point, the 26.869, that's all the way at 26. So that is a lot farther out than the other regressions are, but that would be just about the only unusual feature about this residual plot. If you find yourself with a residual plot that doesn't have any unusual features, that means that the data mostly falls around where the regression line is placed, which is the goal of a regression line, is to fit as many data along it or near it as possible. The last question of this Quideo is the AP question, and the AP question refers to commercial airlines. They wanted to know the operating cost per hour of each flight they had in their fleet, as well as how many seats they had on each of those flights. They sampled 12 aircraft that had as few as 216 seats to 410 seats. And the operating cost ranged from $3,600 to $7,800. For part A of the AP question, it asks for the least squares regression line, and that would be y equals 1136 plus 14.673x. And y represents the operating cost per hour, and x represents the number of passenger seats that each plane has. For part B of the AP question, it asks what is the value of the correlation coefficient for operating cost per hour and number of passenger seats in the plane, and also to interpret this correlation. So the correlation coefficient is r, and they give you r squared, which is 0.57. So you take the square root of that and you find 0.755 as a correlation coefficient. And this just shows that 57% of the variability of operating cost can be explained by the linear relationship between cost and number of passenger seats, meaning that the operating cost is the explanatory variable in this equation, and it explains almost 2/3 of the passenger seat numbers. For the final part of the AP question, it asks, does the line in the scatter plot still provide the best description of the relationship for data in the range of 250 to 350 seats? Why or why not? And it does not, because the 3 points in the upper right-hand corner of the graph, as well as the 2 points in the left bottom corner, heavily influence the least square regression line. They make the line follow a positive direction, and without them, the 7 points within the 250 to 350 range would have a negative line, making the original line unusable. This is the scatter plot that they provided with this equation, and it is clear that those top 3 points in the right-hand corner and the bottom 2 in the left-hand corner really throw off the least squares regression line, because if you only focus on those middle 7 that are in between the ranges of 250 and 350, they would really require a more steep negative regression line, meaning that this original regression line would not be able to work if they shorten the range from 200 to a little over 400 to 250 to 350.
And that's my Quideo.